Good morning, all of you. In today's session, we are going to start with 10th standard chemistry and physics, where series 3 is going to be discussed. In series 1, we performed one activity. In series 2, questionnaire based on that activity and the relevant questions were discussed. And we entered into another concept called Snells Law that is going to be discussed in this series 3. So this is the topic which covered under Unit 4, refraction of light at curved surfaces. Earlier, we completed Unit 1, Unit 2, Unit 3. All these detailed discussion of these chapters available on the channel called World of Competitive Chemistry. Let us enter into our series 3, that is starting with Snell's Law. Right. So what happens when the ray travels along the principal axis? Similarly, a ray that travels through the center of curvature, right? So when the ray, so already we know that this axis which present in the center and moving from C point to P point is said to be a principal axis. On this principal axis, exactly at the center, we will get one point that is denoted with C called center of curvature. So we are incidenting one light source that is crossing from the center of curvature. So what happens to this light ray when it is crossing, when it is passing through the center of curvature, that purely explained based on Snell's law. Let us discuss about what is meant by Snell's law, right? So Snell's law is purely belongs to optics. Optics is nothing but it is the branch of science where properties of light are going to be discussed, right? So in this optics, what happens? Relationship between the path taken by the light ray, and also angle taken by that light ray. So in which path the light ray is moving, as well as what angle it used to generate, and what is the what is its corresponding refractive index. It purely related with refraction of light, so that path as well as angle taken by the light ray and with respect to its refractive index. Refractive index denoted with N1 and N2 because here we have two kind of light rays. One is the incident light ray, second is refracted light ray. Right. So incident light ray, its refractive index is denoted with incident index, and the refracted light ray refractive index is denoted with refracted index. The angle they are generated will be incident angle and refracted angle. So this is purely possible when light ray is traveling from one medium to another. So let us say this is the water medium and also another outside region air. So here N1 is the origin of the light. It is the source of light, for example, where incident light is originated, its path, its refractive index is denoted with incident index N1. And when it entered into rarer medium, it will bend in certain angle, and its path, its refractive index is denoted with the refracted index of this N2, right? So here when theta 1 is considered, theta 1 is nothing but incident angle. What is the angle incident light is generating is called theta 1. The light angle generated by the refracted angle is said to be refracted angle, theta 2. Right. So here is the relation in between this incident and the refracted light of this light of the radiation which generated from the source. So N1 sine theta 1 is equal to N2 sine theta 2. This is the equation, right? N1 sine theta 1 is equal to N2 sine theta 2. N1, N2 belongs to refractive indices of incident and refracted light. Theta 1 and theta 2 belongs to angle generated by incident and refracted light. Right. So based on this, we are going to apply this, what they are asking for. According to Snell's law, ray which travels along the normal drawn in the surface does not deviate from its path. Right. Light incident from the source, so which is moving in a certain path, which will not be deviated in accordance with the Snell's law. Hence, both the rays mentioned about travel along the normal, they are used to pass along the normal, so they will not be deviated. This is in accordance with Snell's law. That is clearly shown in the figure 3. This is the principal axis. On this, we have the point called center of curvature, and this is the curved surface, which is called concave lens, and this is called a denser medium, and outer region is the rarer medium, light originated from the source is moving in the certain path, will not be deviated, and which is moving towards the normal and crossing this center of curvature. This purely obeying Snell's law, right? So what is the Snell's law? We already discussed now. Now we are going to apply in our daily life. What happens to ray traveling parallel to the principal axis? Okay, so this is the principal axis, we can say, and the light is starting from this tip point of this object that is in parallel direction with respect to the principal axis. What happens to that one? What happens? It will be converged at particular instance, right? So whenever light traveling in the parallel direction with respect to principal axis, that will participate in the convergence that purely explained in this camera. How camera is used to give the image. Okay, how camera is used to give the image, that purely based on the question what is asked here. So what happens? Parallel light which is passing with respect to principal axis move to converge. Where it will be converged? At the particular point, all the light rays get converged. That point is said to be a focal point, and that used to generate the image. Wherever convergence of light is possible, there we can find the formation of image, and it used to pass through some lens. So here curved lens is employed in this. So camera is the simplest example for the question what they asking for, right? And next, 4B, 4C, and 4D. Here we are going to apply the concept of refraction to 4 different conditions, right? So what are the conditions? 4A, 4B, 4C, and 4D conditions are going to applied. In all the cases, as represented by the diagram, the incident ray is parallel to the principal axis. So just now we discussed what happens when light traveling in parallel with respect to principal axis. Here also, this is the principal axis. On this we have the center of curvature, and we are originating the light which is parallel with respect to this principal axis, and used to hit on the surface of this curvature, right? So curved surface it is going to be hitting, right? Later it will participate in bending of light called refraction. Bending of light is possible, and it used to cross from this center of curvature. So this is a case 1. Let us discuss case 1. Case 1 is nothing but condition 4A. So here is the 4A. Parallel light was bounced or hitting on the surface of the curvature, and light will participate in bending when it is moving from one medium to another, right? A ray traveling parallel to the principal axis strikes in the convex. Here the mirror is said to be a convex mirror because it is bulging outside convex surface and passes from rarer medium to the denser medium. So outer region is said to be air called rarer medium, inner one is a water called a denser medium, and it is working like a convex mirror where light is traveling in this direction. This is said to be a condition 1. Let us move on to condition 2. In this condition 2, we are taking reverse, reciprocal of the earlier case. In the earlier case, it is bulging outside. In the second case, it is curvature. That means parabola is there, which is said to be a concave, right? The ray traveling parallel to the principal axis strikes on the convex outer region and passes from the denser medium to the rarer medium. So here, we are starting from denser medium. Again, we are considering convex mirror, and denser medium was taken, and from this denser medium entered into a rarer medium. This is converse with respect to the figure number 4A. In figure number 4A, rarer to denser. In figure number 4B, denser to rarer medium. So you can clearly observe that here bending of light is possible and coincided on the principal axis moving towards the normal. That is a condition 1. In condition 2, when it is hitting on the surface of convex lens, it used to move away from the normal. So this process is said to be a reflection. This is called bouncing of the light from the surface and moving in the opposite direction, that away from the normal, away from the center of curvature. This is called a reflection of light. Mirror image will be generated. In case of first one, refraction. In the second one, reflection of light was carried. Let us move on to condition 3. In the condition 3, a light ray traveling parallel to the principal axis strikes in the concave. Here you are going to apply. First two conditions are convex mirror. Here concave mirror is going to be applied and passes from the denser to rarer medium. This will be the denser medium, say water, rarer medium, say air. So here we are going to originate the light from this source. This will be the starting source and it is parallel with respect to principal axis and moving in this direction, hitting on the surface of curvature parabola said to be concave mirror. Here you are going to employ concave mirror. So when hitting on the concave mirror, what is happening? It is bending in this direction. Again, you can say it is called a refraction. This is called a refraction of light, right? So condition 4 we are going to apply. A ray traveling parallel to principal axis strikes on the concave surface. Again, so here principal axis is there, parallel light ray is going to hit on the curvature called parabola. So here we are going to apply the concave mirror and passes from rarer medium to denser. This is converse with respect to 4C, right? Here inner region will be air, outer region will be water now. So when it is hitting on the surface and rarer to denser medium, what happens? It is moving away from the normal. So here this is reciprocal with respect to 4C case. In 4C case, bending is possible. In 4D case, what happens? Reflection of light is possible. Is moving away from the normal. So here two are coinciding. Which two are coinciding? First one is bending. 4A is bending, right? That means refraction. 4B is reflection. 4C is again refraction. That means 4A and 4C are identical, even though we are applying convex and concave lens respectively. But 4A, 4C participate in bending of light towards the normal, towards the principal axis. This is called refraction of light. Whereas 4B, it is moving away from the normal, and even in the 4D, it is moving away from the normal, right? So these two are said to be reflection of light. 4B and 4D are identical in nature, right? So now let us put on some questions here. What difference do you notice in the refracted rays of 4A and 4B? What difference you notice? In case of 4A, what you observed? 4A, when light passing parallel with respect to principal axis hitting on the surface of convex lens, here convex lens, which is bulging outside. Upon hitting, it will participate in bending of light and with certain angle, it used to migrate and reaching the principal axis. Towards the normal, it is moving. The condition is towards the normal. So it is bending towards the normal in case of 4A. This is the case one which we just discussed, that is available in the 4A. Now let us move on to 4B. So in case of 4B, what happens? Again, light passing in the parallel direction with respect to principal axis, hitting on the surface of convex lens, and it is moving away from the normal, the process called refraction, and both are conversely participated. So here, denser medium to rarer medium light is moving. Denser medium light is traveling in the parallel with respect to principal axis. Upon hitting on the convex mirror, it will participate in certain angle. That is the process called reflection. So both are mentioned in the single sentence. In brief, in the figure 4A, ray passing from the rarer to denser medium striking at the convex surface bends towards the normal. In the figure 4B, ray passing from the denser to rarer medium striking on the surface and will participate away from the normal. So this is a condition, main difference between 4A and 4B. To any other question. What would be the reason for that difference? Why difference is possible? In case 1, phenomenon possible is called a refraction due to light from rarer medium to denser medium passing through the center of curvature of convex lens and reaches normal, whereas in the case 2, lens of convex lens and phenomenon is called a reflection of light, where the light passing through the convex lens got bounced away from the normal. That will be the main reason for difference of these two. In the case, the question is, another question we have to observe is, what difference do you notice in refracted rays in the figure 4C and 4D? So what difference you noticed? So we are moving from this origin. This is the parallel line with respect to principal axis, moving from denser medium to rarer. So heating on the surface of concave mirror so that it participate in bending. 4C, refraction of light is possible. In 4D, the parallel line is hitting on the surface of concave and moving away from the normal. This is the process called reflection. Right. So this is very similar to the process carried between 4A and 4B. Here also same, but the lens is different. In the earlier case, we used a convex. In this case, we are using concave lens. Okay. 4C, refracted ray reaches the particular point at the principal axis, converged at the point of center of curvature. Convergence is possible here. Whereas 4D, refracted ray moving away from the principal axis, extended refracted ray backwards along the ray as shown in the 4B and 4D. So the extended ray intersects at the principal axis at the same point. In case of 4B and 4D are identical, 4A and 4C are identical in nature, right? So that is the main difference. What is meant by focal point? So this is the case we are going to discuss what is meant by focal point in this. The point where refracted light rays intersect at the axis in all the above cases is called the focal point. Whenever parallel light rays are used to fall in the surface of the mirror or lens, they're used to converge after hitting on the surface. They're used to converge or coincide at particular point. That is said to be a focal point. This point is called a focal point, or the principal focus of the lens depicted by a ray diagram said to be F. Focal point is denoted with the parameter called F. Refraction of rays of light reflected from the emitted by the object causes ray to form the visual image of the object. Wherever convergence of light is possible, there you can observe its a visual image. You can find the visual image at the point of focal point when all those are converging at the point of F. Right, that is said to be a focal point. It is clearly mentioned in this. We are taking object here. From the tip of an object, you are going to originate two light rays. They are passing from a lens. This is the lens we are inserting here, right? So here, this is the parallel principal axis which is passing through the center of this lens. And here, at the exact center point, you can find the point C called the center of curvature. So whenever these light rays are moving through this one, what happens after moving through this? They are used to bend in certain angle when medium is varied. Let us say this is the rarer medium and this is the denser medium. So that with a certain angle they used to bend, and later they used to converge at the particular point. This particular point is said to be a focal point, and at the focal point, at the convergence of the line, you are able to get its image. In case of this one, image initial object is in a vertical upright, but image generated will be the inverted one. So this is the point called a focal point denoted with F, right? Focal point is a noun and also called as a principal focus. The focus point is the axis of lens mirror to which parallel rays of light converge. Where the light rays are used to coincide with each other, converging with each other, that particular instance is called, that particular point is said to be a focal point, from which they appear to diverge after refraction or reflection. In both the cases, that is either refraction or reflection, in both the cases, the convergent point is said to be a focal point. A center point of the attention or interest is said to be a focal point where the image of that particular object will be generated, right? So by this, we completed entire series 3 of this unit 4, refraction of light and the curved surfaces. Hope this session will be helpful for your preparation. Thank you very much for your consistent listening. Thank you one and all.